Hello again, and now we are going to, let me get this going for you. Thanks for bearing with me. I'm doing my best. Dividing a polynomial by a monomial. Let's get to it. Okay. So when we are dividing a polynomial by a monomial, and we're going to make ours all work out nicely, and I'll kind of tell you what that means. So here we have a polynomial in the numerator. We can have however many terms we want it to have. And we're going to divide by a monomial, just the one term. So we want to check this one term out, and we want to divide it into both of these. Well, let's see, there's a plus sign here, so things might get a little confusing. Let's do a little aside, and let's remember some basic division rules with a binomial or some sort of expression with pluses and minuses over a single term. Let's do this. I'm going to take out the variables. 20 plus 15 over 5. Okay, so I just stole these numbers, put them over here. 20 plus 15, you're all in with the 35, divided by 5, 7. Cool. So we're all good with the 7, but here's the thing. Sometimes we want to cancel. We get a little bit cancel happy. If I cancel the 5 with one of the terms in the numerator, 5 goes into 5 once, into 24 times. Now I've got 4 plus 15. And 4 plus 15 is 19. That's not 7. But I can divide 5 into this side as well. 5 goes into 15 3 times. And yes, 4 plus 3 is equal to 7. Another way that I can look at this is I can take my numerator, 20 plus 15, and I can put each of those terms separately with a denominator of 5. This reduces to 4. 15 divided by 5 is 3, and that sum is 7. So we can split this up and write it separately, or if you're comfortable, you can divide into each of these numerators. So let's first split it up. 15x over the 5x over the 5x. Okay, so let's check out what's happening here. So now I want to do each piece separately, right? So it's not overwhelming. So 20 and 5 reduce. Okay, well, we just did that. So that's going to reduce to 4. I'm going to write my answer over here. X squared over x. Well, x squared is 2 x's, and x is the 1x, and I can cancel one of them, leaving me with x. It's also subtracting my powers. Plus, divides, and I get a 3, and the x's cancel, and that is my final answer. I could have simplified left and right here, or if you're more comfortable, separate it. This guy here, I'm just going to simplify up to the left, simplify up to the right, and I'm not going to leave anybody out. 4 goes into 16 4 times. Oh, and I have x squared and x squared, so that would cancel out. So 4 is all by itself. Plus 4 divides into 4, divides in over here 6 times. Let's make that look like 6. And if I have x to the 3rd in my numerator and x squared in my denominator, I can cancel out 2 of them, and I have an x left in the numerator with my 6. Number 3. There's a lot happening here. Let's do one piece at a time. So we'll look at our numbers, then the A's, then B, then C. First, my numbers. So I have 1, 2, 3 terms. I have to make sure that 7 will divide into each of these coefficients, and it will. So let's see. 7 goes into 7 once. Well, so I feel better, I'm going to write the 1 there. I'm going to leave a space, because that's where all my A, B's, and C's are going to end up, but I'm going to write my minus. 7 into 28 goes 4 times. And again, another space for all those variables. Here's my plus. 7 into 35 goes 5 times. Okay, let's go back and get our a's. My denominator has 2 a's. I have a squared. So I have to make sure that a will divide into each of these a's in the numerator, and it will. So I have 3 here, leaves me with just an a. Here I have 5 a's. Down here I have 2, so 2 of them would cancel and leave me with 3, or a to the third. Same happens here. 5 a's in the numerator here, and 2 here. Cancel, cancel, or subtract your powers. A to the third. Next up, b to the fourth. So I have to make sure that there are at least 4 b's, 7, 6, and 4, in each of these terms, so it divides out nicely. Is it okay if it doesn't? Yes, but for our purposes, we're going to make them all divide out nicely. B to the fourth into b to the seventh, that leaves me with 3. I have 6 b's here, 4 here, leaves me with b squared, and my last term, they cancel. So there will be no b in this last term over here. There we go. C's. I have to make sure that I have at least a c in each of these, and I do. So c and c, that cancels. This term is done. C, that's c to the 9th, so I'm going to take 1 away. And one of them is going to cancel here, and I will have a c. This is our final answer for number 3. Number 4. Let's see if I can do that a little bit. That's not bad. Okay. So for this one, I want to make sure that 3 divides evenly into each term, that x divides evenly, and oh look, if there's extra variables, that's okay. 3 into 12 goes 4 times. And I am going to take care of all my numbers first, leave a space, plus 3 into, ooh, look at that, see what happens. 3 into 3, well that disappears, I'm going to make it a 1. X, and x to the 5th, well if I subtract, that leaves me with x to the 4th. And next over, well that cancels. So there's my 1, don't forget this guy. Okay, so now I have to remember that if an entire term cancels out like this, that it doesn't just go away, it becomes 1. Let's take a look at regular numbers. What if I have 20 plus 5 divided by 5? Well, okay, fine. So this is 25 over 5, and we're all happy that answer is 5. If we reduce to the left and to the right, 4 and 5 into 5, well, I can't cancel it and put nothing because I know this answer is 5. So instead I have to reduce 5 over 5, and anything divided by itself is 1. So there's your 1, 4 plus 1. So we must have that placeholder of 1 if ever an entire term divides out. Last guy. Pause it. See what you can do. Remember, we're going to go through with our numbers, then your A's, B's, C's. So go ahead and try if you want, but I'm going to dive in now. 4 into each of these terms. Start with my enormous fraction bar. 4 into 12, that's 3. Space minus. For all that goes away, I'm going to put a 1 just in case. Plus sign. 4 here, that's 6. Minus, and I'm going to put a 1 just in case. A's. I'm going to subtract 2 A's from each of the exponents in the numerator. That leaves me with a to the 4th. Oh, that cancels. Over here, well, that's going to be just 1a left over, and that guy cancels. All right, it's looking pretty sparse. Let's take a look. B squared. So I have to make sure that I can cancel at least two b's, and I can. So this is going to be b. If I subtract away 2, that's leaving me with 7. B to the 5th. And let's see what's happening here. B squared and b, oh, that cancels. B squared and b squared, that cancels also. C's. I have to make sure that each of these has a c, and they do. So I'm going to subtract away 1 c. C squared, c to the 9th, and that guy just cancels altogether. Oh look, there's my minus 1. So that means that these two terms were exactly the same. It doesn't go away. It reduces. Anything divided by itself gives us 1. At this point, it kind of almost looks like a fraction bar. So what I do is I just kind of do one of these jobbies, and then it looks like we're circling or boxing out our answer. And that's what we can do. So hopefully that helped. There's a couple extra practice problems for you in one of these blocks with the same date as today's date. That's whatever's on this. I think it's March 31. So good luck with all of that.